Now I'll tell you how to make the members of these functional groups, right? So what I'm going to do, I'm just going to divide the board into different functional groups so that you should know that how we can make the members, what are the differences that lie between these functional groups and how we can make the members of these different functional groups, right? So it is ketone, carboxylic acid, and this is ester, right? As I told you, there is a similarity between the aldehyde and the carboxylic acid. So what I'm going to do, I'm just going to make carboxylic acid along with aldehyde so that you should know that what is the similarity, what is the difference between them, right? Similarly, I'm going to draw the members of the ketone and ester together so that you can relate them, right? So see, the first member of alcohol, that is N is equal to 1, you know that for N is equal to 1 we have meth, right? We have the primary suffix, that means which indicates the type of bond. So let it be AN, that is indicating the single bond. But whenever, just remember, whenever you are joining the primary suffix with the secondary suffix, and if the secondary suffix start with a vowel, that what the vowel is? A, E, I, O, U. Right. So if the secondary suffix starts with the vowel, what you have to do, you have to drop the E of the primary suffix. See what I am doing here. I have the word root, I am just splitting them so that you can know in a better way. Meth is the word root, ANE is the primary suffix, and all is the secondary suffix, right? Now see that this all, that means it starts with O, that means it starts with an vowel, right? So if the secondary suffix starts with a vowel, I told you that we have to drop this E, right? Now we can club them up, so it becomes methanol, right? So see how I am writing the formula for it. So meth indicates one carbon atom, so this is what I have written, one carbon atom, right? This second is AN, so I don't have any other carbon, so that means ANE means nothing to me in this case, right? All means OH group, so I've just put one OH, right? So as you can look at the board, that how many valencies of C is satisfied now? Obviously the C valency, only one valency is satisfied, and we are still left with 3, and there is no other atom to pair up with carbon. And as I told you that if there is no other carbon atom to get pair up with carbon, what you have to do, you have to put H with them, right? So this is what I am putting. I'm just to satisfy it, I am putting 3H, and now after putting 3H, the 4 valencies of carbon is now satisfied. And this is the open structure formula, and I can just condense it by just totaling the carbon and the hydrogen. So I can write CH3 and OH, right? I can write it in this manner also, but in order to avoid confusion, just make a habit to write in this form, that means not counting the atoms of the functional group, right? But if you like, like in an exams, you may get the question in which you get the formula like this, because you will be so well versed with these kind of formulas in which you are not counting the atoms of the functional group, right? So just to make you confused, what they will do, they will just club them up and write in this manner. So just be tricky in that case and just split them and just make out that what the given compound is, right? So this is how you're going to write the formula for the methanol, right? I'm giving you one more example. Suppose I am taking an example in which the chain includes the carbon atom 5. The 5 I know it is pent, AN and all. Again, when I have to join it, I just have to drop this E, and after dropping this E, I have to just join it and it becomes pentanol, right? So what I am going to do next, pent means 5 carbons, so I am going to put 5 carbons, right? Then next is AN, that means it indicates the single bond between all the carbon atoms. So I am just going to put all the single bonds. Then it is all, which indicates that it is a functional group, and which functional group, right, it is a alcoholic functional group, that is OH, right? But as I told you yesterday in the previous lecture as well, I told you that whenever you have to put alkenes or alkynes, the double or triple bond, so just put them on the you can say the corner carbon atoms, either on this or that, right? There is a logic between them, because when we name them, we just number them, and the carbon atom carrying the double or a triple bond or a functional group should get the lowest number. This you will be, I'll explain you more in the IUPAC case. So for this moment, just be concerned with it, that when you get, you need to write this all means one all. That means it has to be put on the corner carbon. So either put on that corner or this corner, doesn't make a difference, but put in the corner, not in the mid, don't attach to the mid carbon, right? So this is what I'm doing. I'm just putting this all to a corner carbon. Suppose I put to a this, you can put in the same way to this carbon also, right? So now I'm just going to satisfy the valency, and you know that how to satisfy it by just looking at the bond the carbon is forming. So it is, this carbon is forming 2 bonds, that means 2 valencies are left unsatisfied. So CH2, again 2, so we are left with 2, 2, again 2H is to be put, 2, again 2, and here we have 3. Now we can write the condensed formula, that is C, how many C? 5. How many H? 2, 4, 6, 7, 8, 9, 10, 11. Remember, I am not counting the atoms of the functional group, right? I'll write in a separate order, because now at this moment you are not so much well versed with the writing of these structural formulas. So it is better when you are practicing for the first time, just don't count them up, because if you will count them up, you will get little confused. So in order to avoid confusion, or why to get confused, so it's hardly make a difference, it means one and the same thing. So just don't count these atoms into the with this C and H, right? So this is something we have for this thing, the alcohol, right? So what general formula we have for alcohol? This is CnH2n, right, plus 1, and there is a bond, that is OH. So this indicates the general formula for the alcohol. I think you know that how to make an alcohol. Just write the name. That means if you want to wish to make a compound for a 3 carbon, so write the word root, that is like 3 carbon, it is prop. So prop, ane and all. Drop E, just join them up, that is propanol. Then just you can say write the meaning of each word you involved in the naming, right? That means the prop means 3 carbon, put 3 carbons. Ane means the single bond, put single bonds. All means the OH, just put at the corner. You need to remember that, I told you. So again, then after doing all this, you just need to satisfy the valency. And if how you will satisfy the valency? By putting the H as many as required, right? And then just to get the condensed formula, just club them up, just add them up, but don't add the functional group atoms. You may add, it is not a big deal, or it will be wrong that if you will add, it is just for a moment. I want to tell you that if you will add them and you are attempting it for the first time, so you may get confused, right? So just make a habit to write in that case, but you should be well versed with the other way also, right? So this is how you are going to make the members of the alcohol. Now looking up at aldehyde, we have the CHO group, right? You know that, and the suffix is al. So I am making for the first member, so it is meth, ene and al. Again it starts with a vowel, so I have to drop this E, right? So the name becomes methanol, right? Now I'll write for the meaning, for the words which I joined in this structure, right? Meth means 1 carbon, right? So I have written C. Al, An means single bond, so there is no other carbon, so Ane doesn't make a difference like we did in this case, right? Then it is al. Al indicates CHO, right? So that means CHO like this. So do you think I have written in the right way? No, it is incorrect, because now if you will write one more CHO with this given C, then it will become 2C. So you have to write 1C. So it is a very important point of this functional group, that those functional groups which contain the carbon atoms are counted in a parent chain. That means if there is a functional group which contain the C, do not add one more C of the functional group. Instead of it, make you are provided with the word root, make the functional group out of those carbon only, right? So as it is methanol, so meth means 1 carbon, An means single bond, so no other carbon atom, al means CHO. So I am not going to put one more CHO, I am going to make this C as CHO. How? By like this. Right. So how many valencies are satisfied? 1, 2 and 3, left with 1. So it becomes 1. I'm counting everything, but I'm not counting the functional group. So I have the structure HCHO, right? So, and I think it's clear now why I told you to remember the open structure of functional group as well. See, here if you are not well versed with the open structure, as we know, we can write aldehyde as CHO as well, and we can write in this way also, right? So if you are not familiar with this open structure, so how you are going to satisfy these valencies? So you need to remember both the structures, the condensed one and the open one, just to be thorough with what kind of bonds they are forming, right? So it is the methanol, and just let me tell you that what is the common name for the methanol? It is the formaldehyde. It is the common name, right? And you know that formaldehyde when mixed with water is this thing, the formalin. Formaldehyde mixed with few percentage of water give rise to formalin. And you know where this formalin is used? Have you seen ever the formalin? Yes, you have seen, but you don't know that actually it is formalin. You must have gone to the labs in your schools and all, right? And you must have seen that those specimens, the snakes or the spiders or something like that, they are just enclosed in a jar, right? And it is just surrounded by the water. It is not water, it is formalin, right? So formalin serve as an important use. It is a preservative for storing the specimens, right? So here the formalin, from where this formalin comes, it comes from formaldehyde, and formaldehyde is the common name for the methanol, right? So one more member I'll make for you. Let it say I'll make a third member, right? So I have propanol. Now you know how to write this name, so it's clear now. So again I'm just solving for these words which I attached. Prop means 3, an means all single, Al means CHO. So I am not going to put one more CHO, I am going to make one CHO out of these carbon atom only. And which C I am going to make, which C I will prefer in making CHO? Again the corner one, either of this corner or of that corner. So see, I am making this corner one, right? So again I am just going to satisfy the valency. 2 bonds already done, 2, this 4 is satisfied. I am counting everything, but I am not counting the functional group. Sorry, this is 3. See, it's 1 valency, so it comes out to be 3. So 3, 4, 5, HR. Again, I'll make, I think there is some confusion in it. Right, so again, I'm making for you. Prop means 3 carbon, AN means all single bond, Al means CHO. So I'm making this corner one as CHO, right? So I'm counting the valency now. See, 1 valency is satisfied, so that means I need to put 3H. Here, 2 valencies are satisfied, so I need to put 2H, right? So when I'll count them, what I'll have 2C, 5H and CHO. So this is the formula for the propanol. So what is the important thing in this aldehyde is that whenever any functional group contains the C atom, then you don't need to put an extra C to it. You have to make the functional group out of those parent chain carbon atoms only, right? Similarly, we are going to make the carboxylic acid. Carboxylic acid is COH. Other formula is this. You know that why it is important to know this open chain formula. You know that because here we use that, right? If you are not well versed with the, you can say the number of bonds it is forming, how you are going to satisfy the valency, right? So you need to remember both the structures, right? And the suffix is oic acid. So again I am making the first member, that is the meth N oic acid. I have dropped E again because O starts with the O is a vowel. Right. So what I am just going to solve for these words, meth means 1 carbon. An, again if some other carbon atom is present, then only An serves as a sum function. Otherwise it is a member of alkane, we know that, but the functional group which is present is oic acid. I am not going to put another COOH, I am just going to make this carbon as COH. So this I have made for you, right. So how many valencies are satisfied? 1, 2 and 3, we left with 1. I am counting everything, but I am not counting this. So what is the difference you can see in this and this? There is hardly a difference of O here. Here is an O and in this case there is no O. So similarly you can make this member of this. So what you will get, the same formula you will get. See what we did. The only difference lies you will get the O along with it. So this is how you are going to write the formula for the propanoic acid. And likewise you can write for the 10 carbon atoms as well, right? So now let us see for ketone and ester, right? ketone and ester, they have some property different from this alcohol, aldehyde and carboxylic acid. Now what is it, right? So first of all, to make you familiar with that property, I want you to tell you that I think you remember that ketone functional group is CO and ester functional group is COO. It can be written as this, it can be written as this, right? Now that means they have only one carbon, right? But the main property and the main similarity between this ketone and ester, they don't get attached to a carbon atom which is at corner, right? They need to have a minimum one carbon on each side, right? So that means the first member is not going to be methanol. Suppose if I try to write methanol, let us see that what happens. Met means one carbon. An means again no other carbon atom, un means O. So it is not like that you will make like this and you will just satisfied with H and H. No, it is not like that. So first member of methanol is minimum of 3 carbon atoms because it get attached in a way that it gets minimum of one carbon at each side. Minimum I am talking about. Maximum it can have as many, right? So the first member is minimum of 3 carbon atoms, that is the proper non. So prop means 3 carbons, un means, so obviously you are going to make the middle one, right? And an means single bond. Now count the valencies, again 1, 3 are unsatisfied, 1, 2, 3, 4 satisfied, 3 unsatisfied, so it comes out to be this. I am totaling everything but I am not counting this functional group, so I can write in this way. So I think it's clear now. The main important issue related to it is that it need to be attached in such a way that it gets minimum one carbon on each side. So that is why we have its first member not methanol, not ethanol, it is the proper non. That means the minimum, the group minimum word root which starts with 3 at least. Similarly, we have in this case, so how we put like we have 3 carbons, minimum again 3 carbons are required, so it becomes propno 8. The prop means 3 carbon, An means single bond, O8 means COO, and you need to satisfy the valency. You are counting everything but we are not counting the CO. It is the similar way, the only difference is that here is one more O attached in this case, right, and it is not present in this case. So this is how you are going to make the members of the alcohol, aldehyde, carboxylic acid, ketone and ester, right? And you know that what is the common name for the methanoic acid? It is the formic acid. Formic acid is the common name for the methanoic acid, right? And what is the formula for the ethanoic acid? You know that? Ethanoic acid is actually a main important component which you use in your kitchen. Ethanoic, eth means 2, an means single, oic acid means this. This is a ethanoic acid, and common name for this ethanoic acid is acetic acid, which you call as vinegar. So you must have come across vinegar in your when your mama is making something in the kitchen. So vinegar plays an important role in kitchen. So it is actually a ethanoic acid. That means the functional group present in it is a carboxylic acid. So this is how you are going to make the members. I think it's clear. So before you make the members, just go through that chart that I told you, that you need to remember the name of the functional groups with the how they are indicate, what kind of group indicate that particular functional group, and what are the secondary suffix that are actually present, right? And few more tips is that whenever a functional group name starts with A, E, I, O, U, then you have to drop the E of the primary suffix. Important thing, don't forget, right? And the second important thing is that whenever a functional group carries the carbon atom as a main component of the functional group, like, or you can say if the functional group includes C in it, then you don't need to put an extra C. From that parent chain, you have to make either of the carbon as that functional group, right? So that means it is counted in a parent chain. This is what I want to tell you. The third thing, important thing is that when you are making ketone and ester, their first member is minimum starting with the 3 carbon atoms, right? So this is how you are going to make the you can say members of these functional